But what we're doing now is in section 3.6, we're adding complex zeros. If you notice, the last two questions said find the real zeros of the function. Okay, we're going to learn what it looks like when numbers are not real numbers. So far, probably for most of you, the majority of numbers that you deal with are real numbers because it's what we typically use. But there are certain situations, a lot of them are in some different science applications of modeling different things, where we end up dealing with what are called complex numbers. Okay, so complex numbers have, well, this is the deal. Most basic complex number is, we label it with an I. Okay, and I is defined to be the square root of -1. Okay, and the reason that's called a complex number is because if you are taking the square root of something, that means two numbers multiply together to equal that number. Like the square root of 9 is 3 because 3 times 3 equals 9. Square root of 16 is 4 because 4 times 4 equals 16. There's no number that you can multiply by itself and get a negative answer. Does that make sense? Because, you know, like 7 times 7, if they're positive, they multiply together to be a positive. -3 times -3, multiply them together, you get a positive, right? So if you multiply something by itself, your answer will always be positive if you're using real numbers. So that's where these numbers come in. What happens when we have a negative inside of this square root sign? Okay, so this I is commonly called an imaginary number, and it's called imaginary not because it doesn't exist, but because it doesn't fit into the real number system, the real number group. So any real multiple of I is also an imaginary number. So here's how we look at this, and here's our property that we're going to use here at the beginning. We're going to work with these imaginary numbers and try and get relatively comfortable with dealing with them. So if you have a negative inside of a radical like this, what you do is you're going to take out the negative, and it will become an I on the outside of the radical. That tells us, because of this negative, this is actually an imaginary number. Okay, so what happens is, again, if there's a negative, the negative goes away, and we put the I on the outside. That tells us this is imaginary, and the other part just stays there. If we can simplify it, we'll simplify it. If we can't, we'll just leave it. So you'll notice on your sheet, we've got some examples here to try and help us with this property. Okay, so the first thing that we want to do, and we've got 4 different numbers here. Notice they all have negatives in them. But the first thing we want to do when we see a negative in here is we want to take it out. So when we take out that negative, we have to write down that, hey, this is an imaginary number. So we have I, and then we have the square root of 8. The 8 is left inside. Now we're not done, because if you remember earlier in the semester, we learned how to simplify these. Remember how we did it?
Yeah.
We would take that 8 and we'd break it up, and we would look for pairs. So how can we break up 8? 2 times 4, I think, is what I heard. I heard a lot of things, but I think that was the one I heard. And the 2 is done, and then 4 breaks up into 2 times 2. So remember, we're looking for pairs. We're looking for 2 of them. So notice we have a pair of 2s. Because of that, we can take a 2 out of the radical. Well, let me write this so you can see it. So what we actually have is we're going to have 3 2s on the inside, because 2 times 2 times 2 equals 8, right? We're just breaking it up into its little parts. Does that make sense, that 2 times 2 times 2 is 8?
Yes.
Okay. So if we have 2 of a kind, because we have that 2 of a kind, they're able to escape. That's why we call this the jailbreak method. They're able to escape from the jail radical here. So now on the outside we have this I, but for some reason only one of them actually escapes. So we just have a 2 on the outside, and then the 2 that stayed on the inside just stays on the inside. Okay. Now when we write our final answer, we want the I to be behind this 2. So we would write 2I and then square root of 2. And that would be our answer. Okay. So we've done the breaking down the radical before, but the I is the new part. But it allows us to review some of those things we've done that we maybe haven't worked on for a little while. Okay. So let's look at that second one. What would you do first on the second one? Take out the negative and put the I here, right? Now, can we break up the 2? No, so we're done. That's done. So that one was easy, right? We like that one. What about the third one? What would we do first? Take out the negative and put the I here. And we have a 12. Now we have to break up the 12. How can we break up the 12? Be careful. We're multiplying. So what? You said 6 times 2? Okay, 6 times 2 will work. And then how do we break up the 6? 3 times 2. So notice we've got what's actually in here is 2 times 2 times 3, right? 2 times 2 times 3 is 12. And since we have a pair of 2's, we're going to be able to take that out. So it's going to be, we're going to put the 2 in front of the I, and then what's left inside the radical? The 3. So that would be our answer.
So anything that's a pair comes out.
Anything that's a pair comes out.
So if it was 3, 3, 2, 8, then
The 3 would come out. Yep. And we'll see it. We're going to probably be doing a lot of these. So we'll get plenty of work with those radicals again. How about this one? What do we do first? The I. So take out the negative and put the I in front of it. Okay. And then what are we going to do with that 36?
6 times 6.
And do we see that 36 is actually a perfect square?
Yeah.
Right? The square root of 36 is what?
6.
6. Yeah, 6 times 6. So this one, we just get 6 times I. And I guess I didn't say it, but these things are all just multiplied together. So this is 2 times I times the square root of 2. And this is I times the square root of 2. And 2 times I times square root of 3. We just don't write the times signs in between them, but they're really all multiplied, right? If there's no symbol in between, it's automatically multiplication. So 6 times I is the last one. Yeah.
So you wouldn't go, like you did that.
If you're breaking it down.
Then you wouldn't do the 2 times 3.
Okay, so are you talking about this one?
Yeah.
Okay, so what we would have is 36, and if we break up 36, how do we break it up? 6 times 6, and then we break this up into 2 times 3 and 2 times 3. So look at what we would have. I, and then 2 times 2 times 3 times 3. So we can take out the 2, and we can take out the 3. And since they're all multiplied together, just 2 times 3 would give you the 6. So you could do it the same way if you don't recognize that square root of 36 is 6. But if you can recognize it, then it's just quicker. But does that make sense? You'll still get the same answer? Okay. Any other questions on that? No, you're giving me a look. Did you have a question or not?
Back to the I2 times 2 times 3.
This one?
Yeah.
Yeah.
Where did you get those from?
These numbers?
Yeah.
Okay, so we broke up the 12
Yeah.
into 6 times 2. And then 6, again, multiplying, breaks into 3 times 2. So we had two 2's. So that's the first 2. And then we had a 3.
Oh, so you just collect them.
We just collect them inside. And then anything we have a pair of, we can take out.
There's over there. It's 2, 3, and 2.
Yeah. Does that make sense?
No, it does.
Okay. Any other questions? All right. So we got our answers, and fortunately, I think we're right on all of them. So we're going to go on. Okay. So an imaginary number is those things that have the I in them, right? We just had 4 examples of imaginary numbers. When we put together the imaginary numbers with the real numbers that we've been dealing with, we get what is called a complex number. And so a complex number is always going to look like this. You'll have a real part that doesn't have an I in it, and then you'll have the imaginary part that does have an I in it. Okay? And this is this A plus BI, real part first, imaginary part second. That's standard form. So anytime we write these, we always want to write them with the real part first and the imaginary part second. Okay? And you'll see how we do it in these examples. But the A and the B are going to be real numbers. So it just means we've got a number and then plus another number times I. That's the makeup of a complex number. So there we go. Let's simplify these and then write them in standard form. Then identify the real part and the imaginary part. I think there are some questions like this on the homework, so I want to make sure we practice identifying the real part and identifying the imaginary part. So let's start with this. Square root of -9. What do we want to do first to start simplifying this? Wait, say that again.
Negative.
If we're just working with this -9, we're going to take out the negative and put the I there, right? We're not going to do anything with the 6 yet. We'll do that in a second. Then what do we know about the square root of 9? It's 3, right? Square root of 9 is 3, so we can just write that down. So I times 3 plus 6. Now, up above, we see standard form. Standard form says, what goes first?
Real number.
The real number goes first. And so I heard several people say it. That is the 6. Okay, plus, and then the imaginary number goes second. And the way we would write that, instead of I times 3, we would write 3I. And that is all. You cannot combine that real number with the imaginary number because they're separate groups. Okay, real numbers and imaginary are separate groups. We can put them together with a plus sign in between or a minus sign, but we can't add them or subtract them from each other. Okay, does any questions on that first one? All right, let's try the next one. What are we going to do first here with this square root of -18? Take out the negative and put an I here. Okay, unfortunately, there is no nice even square root of 18, right? So we've got to break it up. 18, how can we break up 18? 9 and 2 is correct, and then we can break up the 9 again. How do we break that up? 3 and 3. So that means we have, and I just always put them from smallest to biggest, no big deal, but so that they're definitely in order. And we've got a pair of what? 3. So we said that we can take out the 3. So 3 times I, and then the square root of 2 stays inside, and then we've got plus 7. Is that how we want our answer to be? No, because what do we want to go first? The real part. So we're going to put what first? 7, and then we're going to have plus 3I square root of 2. And that will be our answer.
Love it.
Now, one thing that I will mention is when we're doing this, and we haven't had to worry about it yet, but in this case, this plus sign goes with this 6. So when we move it to the front, that's why this is a positive 6, because that plus sign goes with it. Since this is a positive 3I, this plus sign goes with this one, and that's why that's a positive. But sometimes when you have negatives in there, you have to make sure the negative stays with what it's with. Yeah.
So, for example, on that first one, instead of plus 6, it was -6. It'd be -6 plus 3i.
Yeah. So if we had this is what you're asking, right?
Yeah.
So the negative goes with the 6. So you're right. It would be -6, and then this would be plus 3i. That makes sense because the negative goes with the 6, and in our made-up example here, the positive goes with the 3.
And if they were both negative, it'd be negative.
Yeah, if they're both negative, they're both negative, but you just have to make sure whatever sign is right in front of the number stays in front of that number. Okay. Any other questions on example 2 here? All right. So let's see. I think we got our answers, and they look good. So let's go on. In order to add complex numbers, it's actually fairly easy because the I part kind of acts, it's not a variable, but it kind of acts like a variable. So if you look at what happens if we've got this complex number, real part, imaginary part, plus this complex number, real part, imaginary part, look at what we do. We add the real parts together, right? And then we also add the imaginary parts together. And of course, with those being numbers, we just add them together, and that's going to be a number times I. Okay? So it's like we're adding like terms. You know, like, so for instance, 6i plus 3i is 9i, just like 3x plus 6x would be 9i, or 9x. Okay? So it acts like a variable. In almost every case, there's one time where it doesn't, and we're going to get to that in a little bit. So let's practice some adding and also some subtracting. All right. Looking at this first one, we can see it says plus in between them, right? Okay, so we are going to do what? Add, because it says plus. So we're going to look at this, and again, think adding like terms. The 3 and the 2 are like terms. They're both just numbers. They're real numbers. What do we get when we add them together? 5. This is a negative 1i, and this is a positive 3i. When we add those together, what do you think we'll get?
2i.
Plus 2i. And that's it. We've added them together. Okay. Now the next one. 2i, which is an imaginary number, but it fits in the complex group. And then minus 4 minus 2i. So again, we are adding, right? So if we add because we want the real ones to go first, if we add the real ones together, what are we going to get? Just the negative 4 is the only real part. So negative 4. And then if we add the imaginaries together, what are we going to get? Positive 2i plus a negative 2i is 0i. Now, what do we know about multiplying something by 0? It's 0. So do we even need to write that down? No. So this is just going to be negative 4. The imaginary part canceled out and went away. That makes sense? It'd be like if you had 2x minus 2x. It turns to 0.
Just gonna leave it as negative.
It is negative 4, yeah.
Yeah, but the plus 0i, I was just
Okay.
writing that down.
Yeah. I just don't want you to think it's an I. It's not that the 2's cancel out and the I stays there. The whole thing cancels with the whole thing. Okay, now here's where it gets a little bit tricky when we add subtraction into it. Okay, so this one's fine. This is addition. We're okay with that, right? But this one is subtraction. Do you remember what I told you back a couple, who knows how many weeks ago? Several weeks ago. What do we do instead of subtracting things like this? Not multiply, but we add the opposite. We add the opposite. So we change it to addition. And then this becomes a positive 2 and a negative 3i. And that way we're always adding because we know how to add, right? But subtracting gets a little bit weird and people forget things because they subtract. I'll just tell you what usually happens. They'll subtract the first one, but then they add the second one. So to avoid that problem, do you remember how when we were doing division, long division, and I said draw the line and change the signs? That's why, because people usually mess up when they do that. They only subtract the first one and not the second one. So we're going to take care of that right here. We're going to change it to addition. And now we just add. So real parts, 3 plus 2 plus negative 5 is what? 0. Okay, our real part is 0. And then we've got imaginary, negative 3i and positive 1i. Negative 2i. So again, just like up here, do we need the 0? No. So we would say our answer is negative 2i. Okay. So again, the last one has addition and subtraction. So what are we going to do to that subtraction? Change it into addition. And so when we change it to addition, it's like the negative is distributing through the parentheses to both of those things. Okay. So what do we get when we add the reals? 3 plus 4 plus negative 7. We get 0. So once again, our real part is 0. Then the imaginary is 2i minus 1i minus 1i. And that is 0. So what is our answer this time? 0. So actually, everything canceled out to be a 0. That makes sense?
0 cancels out.
What do you mean?
It was 0.
You mean 0 times I? Yeah, it just becomes 0. 0 is 0. Yes, ma'am.
So you're gonna change like the positive 4, you're gonna turn to negative 4, and that.
Are you talking about right here?
Yes.
You don't have to do that on this one because this one was already adding. It's only the ones that are subtracting. So because it's subtracting, that's why we changed these.
So only one of these.
Only subtracting. So that's why we did it right here, because this one is subtracting, but we didn't do anything here. Okay? And this one was adding, so we didn't do anything. This one was adding, so we didn't do anything. The only time you're going to do that is if it's subtraction. Then you'll change them both. Subtraction, change them both. These over here, we didn't have to do anything with.
Oh.
Okay? Does that make sense?
Mm-hmm.
Okay. Any other questions on these? Check our answers here. Looking good so far? Good? Any questions before we go on? All right. And now I will warn you, I added one example at the end today because I realized there was something that was missing that I needed to add in there. So there is one more example than what you have on your papers. Not that we're close to that yet. It's at the very end, but okay. Now, with this one, what are we doing this time? We're multiplying, right? Find the products. So multiplying is where we get to this one time where these i's work a little bit differently. So let's take a look at this. But we're going to start out by simplifying. So with this first one, we want to take out the negative and it becomes I. And then what do we know about the square root of 4?
2.
It's 2. So I'm actually just going to write 2i. Is that okay? Times, and you can see your times sign there, times. And then here, again, we're going to have an I and the 4, right? So 4i. Now, when we multiply these, remember what I said? These are all just actually multiplied together. So we multiply the 2 and the 4 together, and we get 8. Now, here's where you have to be careful, because this is where people tend to mix it up. When we multiply I times I, what do you think we get? I squared. Okay, we get I squared. Just like if you multiply x times x, you get x squared. But here's the difference. And write this down in your notes. Well, maybe not the first part, but if you remember back at the very beginning, we defined I as the square root of negative 1, correct? That's at the very first thing we had written down. Here's one step further than this. If this is true, then I squared is equal to negative 1. You're going to want to write that down in your notes because we're going to use it all the time, anytime we see an I squared. Okay? And this is, like I say, this is the one time it acts differently than an x. Because in x's, you don't just replace x's with other numbers randomly. So right here, this becomes 8 times negative 1. The I squared is replaced with negative 1. So then we just multiply, because this is multiplication, right? 8 times I squared. So 8 times negative 1 is negative 8. Now, the easy way eventually that you might learn to do that is it just changes the sign, right? Multiplying by negative 1 changes the sign. Okay?
If you see the I squared change.
If you see the I squared is going to go away and the sign is going to change. But what's actually happening is it's turning into a negative 1, and you're multiplying by negative 1.
So the answer for that would be negative 8.
Yep. So that is multiplying two imaginaries together that are inside the radicals. Now let's go down here. When we go down here to these bottom two, do we see that we have to use our distribution method where we distribute?
Yes.
Okay, but notice, and again, this is a thing that students tend to get mixed up. How do I know this is multiplication? There's no symbol in between these two, right? How would I know if it was addition? There'd be a plus sign in between them. Or subtraction? There'd be a minus sign in between them. But what happens is we get so worried about multiplication like this, I almost always have students on a test that they will see something that looks like this. And and they will completely ignore the fact that there's a plus sign in between them, and they will multiply them anyway. Okay, so I'm going to warn you now, please don't do that. Because you're taking a problem that's really easy, and you're making it more difficult. Right? Because adding was easy, right? I think, right? Hopefully. Okay? All right, so just be aware of that. And I'm warning you ahead of time so you don't do it. But that's in high school, I see that all the time. Okay. But you guys are not high schoolers, so you're not going to do that. All right. So we want to multiply. We want to distribute. So we're going to multiply 2 times 4.
8.
And that's 8. And then we're going to multiply 2. And remember, this is 3 times I. So 2 times 3 times I. What does that equal? 6 times I. Right?
What did he say?
It's 2 times 3i, which means 2 times 3 times I. So it's just 6 times I.
So we're still at 2.
2 is real number.
Yep.
And then 3i
Is imaginary.
So
That's right.
can we
can-
multiply?
You can multiply, you can't add or subtract.
Okay.
Like I can't add these together because they're not like terms. Okay? But you can still multiply them because what you're really doing is you're multiplying the real numbers that are in front of the I. That makes sense? You're multiplying the 2 and the 3. It's 6, and then the I just sits there. Okay, now we want to multiply the negative 1i, because that's what this is, right? Negative 1i times 4, negative 4i. And then the negative 1i times positive 3i. And again, here's where people tend to mix things up. What's it going to be? Negative 3i squared. People will just put an I there and they forget the I squared part. But that's very important because what do we know about I squared? This is really a negative 1. So that means all of these are the same, but what is this last term actually?
Negative 1.
Negative 3 times negative 1 is plus 3. So that I squared, the I squared goes away and it changes the sign. Because that's what happens when you multiply by negative 1. Okay?
Plus 3.
Now we're not quite done. We got to combine things, right? What can we combine?
11.
8 plus 3, right? Is 11. And then imaginaries, what happens when we combine those? 2i, so plus 2i. And once you get there, again, you can't combine the 11 with the 2i, so you're done. Real part first, imaginary part second.
Can you do anything with the 4 and the 6?
With these two?
Yes.
Yeah, we added them together. So 6i minus 4i, that's how we got the 2i. Does that make sense?
Yeah,
Okay.
you're adding.
Yeah, we're adding, but one of them is negative, so it looks like subtraction. Okay, does that make sense for that first one? Do you see how we're going to do the very similar thing on the next one?
Mhm.
Okay, so what are we going to do first? 3 times 3. 9.
6i.
And then 3 times a negative 2i gives us, you're right, negative 6i. And then 2i times 3 is going to be positive 6i. And then for this last one, 2i times 2i times negative 2i is going to be negative 4i squared. That makes sense? 2 times negative 2 is going to be negative 4. Now, so is everybody okay with that, the distribution part? What happens because of this I squared?
Minus.
This is a negative 1, so negative 4 times negative 1 makes that into plus 4. So we've got 9 minus 6i plus 6i plus 4. Real parts, 9 plus 4,
13.
13. Imaginary parts, negative 6i plus 6i
0.
cancels out, right? 0. So we don't have to write it down. It's a 0. So our answer there, 13. Okay. Now I want you to notice something. In this second one that we did, the answer was just real, right? There's no imaginary part. Does everybody see that? There's no I. The reason that happens is, what do you notice about these two things that we multiplied together? They're almost exactly the same, aren't they? What's the only difference? The sign in the middle. And this is going to be important in a little while, later on tonight. But when we multiply things like this that are exactly the same except for these signs in the middle, that will always happen, and you will always end up with just a real number. And that is something we're going to use to our advantage in a little bit. Okay?
So is it always or almost always?
Always.
Always.
Always. If that middle sign is the only difference between them, always. Okay? So -8, 11 plus 2i, 13. And it is an always. And I could show you, because we could do it with a generic like a plus bi and a minus bi, so it doesn't matter what the numbers are, and we can multiply them together and the i's will all go away, no matter what. I'm not going to do that, but we could. That would just be extra time. I could show it to you personally if you want to see it. All right, so this one, notice this is probably a little bit easier because it's only one parentheses and a 4i, right? But what do we have to do when you have this thing on the outside of your parentheses? We've got to distribute, right? So, but it's just one thing to distribute. So we multiply this times this, and what do we get when we multiply 4i times -1? -4i. What do we get when we multiply 4i times 5i? Plus 20i squared. Now, once again, what do we know about I squared? It is a -1. So what happens to that term? We've got the -4i. What happens to this? -20. Is everybody okay with that? It's 20 times -1. Makes it -20. And we're almost done, but what do we need to fix here? The real part goes first, -20. The imaginary part goes second, -4i. And that's our answer. Okay. Is it making sense so far? Eyes aren't super scary, are they? Not today. Tomorrow they will be. Oh no, I'm not in the safety of the math room. They're scary now. Okay. So are we good with that first one?
Yeah.
Okay. Now for the second one, we have to be careful, because what does it mean to square something? You multiply it by itself, right? If you have 7 squared, it means 7 times 7. If you have -8 squared, it means -8 times -8. So that's where we have to be careful here, because we can't take a shortcut. There's no shortcut here. We actually have to do 3 plus 2i times 3 plus 2i. Okay? And so we're going to do the same thing that we did before. Now, here's what we have to think about. Remember that one that was really, really nice when this sign and this sign were different? Right? How it turned out to be real? We're going to find out what happens here. We're going to see, does this one turn out to be real also? So let's take a look. We've got 3 times 3 is 9. 3 times 2i is 6i. 2i times 3 is 6i again. And then 2i times 2i,
4i squared.
4i squared. What do we know happens to this term right here?
-4.
-4. So I'm going to rewrite this. 9 plus 6i plus 6i minus 4. So real part, 9 minus 4 is 5. Imaginary part, 6i plus 6i. 12i. Does it cancel out and become really nice for us? No, that only works when you've got those middle signs different. If they're the same, you still get a complex number.
Same thing.
Same thing if they're both negative. Yep, they have to be opposite signs in the middle. Okay? Any questions before we go on? So we've done addition, we've done subtraction, which we just turn into addition, right? We've done multiplication, and it's all so far so good, right? All right, let's move on. And we already mentioned this. We just didn't talk about the special name. Those ones that we did earlier where it turned out to be really nice, they're actually called complex conjugates. You don't have to memorize that word, but that's the name of those things when they're exactly the same except for that middle sign. Okay? So complex conjugates, notice they're exactly the same except for the middle sign is different. Okay, so I think our example was what, 3 plus 2i and 3 minus 2i, right? So notice the only difference between these two, they have to be identical except this sign and this sign, the signs in the middle have to be different. If the front signs are different, that messes everything up. Okay, so it has to be the middle signs that are different. Okay, so the middle sign. It's almost like I'm emphasizing the middle sign has to be different, right? Okay, so conjugates are useful because, and we already saw this, when you multiply these two conjugates together, you get just a real number. The i's go away. Okay, now this is the special pattern. If you want to learn this pattern, that's fine. But if you go back to our example, which was 3 plus 2i and 3 minus 2i, we got an answer of 13, right? If you look back in your paper, well, here's what they're saying. The first part is 3. We can do that squared plus the second part is a 2. We can do that squared, and that's 9 plus 4, which is 13. And again, that will always work that way. So if you want to learn that pattern, that's fine. But to me, it doesn't take very long to just multiply them and get the answer and see that the middle cancels out. But if you want to use the pattern, you can. It will always work. Okay? So, notationally, this is a notation that's sometimes used for the conjugate of a plus bi. So if you see this, it means find the conjugate of a plus bi, which means you just write a minus bi. Or I could write this with numbers. What would this equal?
7 plus 2.
7 plus 2i. It's just asking you to write down the conjugate. Okay. And the middle sign just has to change. Not the first sign, but the middle sign. Okay. All right. Let's go ahead and look at division, which is really a weird way to say this. I mean, yes, it's division, right? Because it's this divided by this. But the weird thing is we don't actually do any division. We don't divide. What we do is we simplify. Really, that's really what we're doing. So when we simplify, and it looks like division, when we simplify, what we want to do is take it from what it is and write it in standard form. Okay? Because unfortunately, it's not just easy. You can't just take the 2 and the 4 and put them together and the 3 and the 2 and put them together and say, ha-ha, standard form. It doesn't work that way. So what we have to do to put it into standard form is, the problem is this I in the denominator. We don't want it to be there because that's messing up our standard form. So if you think back to what we were just talking about, conjugates, what we're going to do is we're going to multiply our denominator by 4 plus 2i. Because what's going to happen when we multiply these together? The I is going to go away, right? And we don't want that I down there. But if we multiply the bottom of a fraction by this, we have to multiply the top by the exact same thing. So we're actually, instead of division, we're actually going to multiply twice. So that's why it's not really division, it's really more simplifying. Okay? And I should put parentheses up here. So let's go ahead and let's multiply and see how this works. We're going to multiply, I'm going to do the top first. So 2 times 4 gives us 8. 2 times 2i gives us 4i. 3i times 4 gives us 12i, and that's positive. And then 3i times 2i gives us
6i squared.
6i squared. We'll come back to that. Let's go ahead and take care of it now. What happens with this 6i squared? It turns into a minus 6. So I'm just going to cross this off, and I'm going to put minus 6, because that's what it turns into. On the bottom, again, you can use your pattern. I'm just going to go ahead and multiply it. So 4 times 4 is 16. 4 times 2i, 8i. negative 2i times 4, negative 8i, and then negative 2i plus times plus positive 2i, negative 4i squared. Okay? Now, again, what happens to the negative 4i squared? It turns into plus 4, right? And again, that will always happen because it's always going to be the signs are different, so it's going to be minus whatever I squared. And what else happens in the denominator?
28 cancels.
The 8i and the negative 8i cancel out, as they always should if you did it right. So, what do we have on the top? We have 8 minus 6 for the real part, and that is 2. We have 4i plus 12i, and what is that? 16i over, and then on the bottom we have 16 plus 4, which is 20. Now, we're really close, but it's not quite in standard form yet. Because remember, standard form should be a number, and then plus or minus a number times I. So here's what we do to finish this off. And we've done this before when we had radicals, but you may not remember it, and that's fine. But we break this up into 2 separate fractions. Okay, the 20 goes underneath both parts because the whole thing is divided by 20, right? So the 2 is divided by 20, but also the 16 is divided by 20. And so we just break it apart into 2 things, each divided by 20. And then the nice thing is we can reduce them. Because how does 2 over 20 reduce? 1/10 plus, and then how does, this one's a little tougher, how does 16 over 20 reduce?
4 by 5.
Yeah, you can reduce them by 4, so it ends up being 4 over 5 and I. And so that is division, but it's really simplifying and putting it in standard form, right? Because what is your real part? 1/10. What's your imaginary part? 4/5. And I just realized earlier when it asked us to identify the real part and the imaginary part, we never did it. So we're going to practice that now. So real part, 1/10. Imaginary part, 4/5. Okay. So that's how you do division. You really just multiply twice and simplify. All right. And I think we have another one like that, right? So there's our answer if we reduce it. So again, division. What are we going to do to work through this?
We're gonna change the bottom.
We're going to change the bottom, and instead of negative, you guys have all been in the right spot, but what's it actually going to be? Negative 2 minus 3i. You guys were all really close, like circling that answer, and we finally got there, I think. So does that make sense? That that's what we're going to multiply by. The only thing that changes is the middle sign.
No question. Does it always have to be the bottom?
Yes,
Okay.
always has to be the bottom. Because we always want to turn the bottom into just a number so that we can break it up into its 2 parts.
So we're multiplying.
Yep. And then because we multiply the bottom, we have to multiply the top by the exact same thing. And I guess I should emphasize this. Why is this okay? What is, if we just look at this part, if we looked at this as a fraction, which it is, what is that equal to? 1. Right? I don't know who said it, but you're right. Whoever it was that said that, you're correct. Because something divided by itself is 1. And what happens when you multiply something by 1? It's the same as what it was when you started, right? So it's going to look different, but it's the same. It's equal to what we started with. That's why we can do it. Okay? So I should emphasize that. That's why we can do this, because it's just equal to 1. All right, so let's go ahead and let's multiply. So 1 times negative 2 is negative 2. And then 1 times negative 3i is negative 3i. And then negative 5i times negative 2 plus 10i, correct. And there's a negative 3i plus 15i squared. And I will pause there for a second to make sure everybody's caught up and okay with that top multiplication. Is everybody good with that? Then what do we want to do because of the I squared? And it'll be what? Yeah, it's going to be minus 15, right? Just changes the sign and the I squared goes away because it's a negative 1. All right, let's multiply in the bottom. Negative 2 times negative 2. 4. Negative 2 times negative 3i. Positive 6i, that's correct. Positive 3i times negative 2. Negative 6i. And then positive 3i times negative 3i. Negative 9i squared. And what happens, again, because of that I squared? It becomes plus 9. Okay? And what else happens on the bottom? They cancel out, which they always should, right? That's how we set this up, so that that would happen. So, in our numerator, up on top, the real part, negative 2 plus a negative 15 is what? Negative 17. The imaginary part, negative 3i plus 10i is 7i. Very good. And in our denominator, 4 plus 9, 13. Okay? Now we're almost done. What do we have to do? Break it up into two parts. So this will be negative 17 over 13 plus 7 over 13 I. Can we reduce either of those? No. So this is our answer. Okay. Now, like I said, I've got this one example that I had to add in because I realized we didn't tie this back together. And so there's one example we're going to do yet. Is everybody okay with this? With all those different adding, subtracting, multiplying, dividing? Okay. So here's the example I added. Oh, that's the answer. Here's the example I added in. And if you have an open spot or just put it on the side, it shouldn't take us very long. It's just I want to make sure we understand why are we even doing these imaginary numbers. It's not just so you can have something fun and exciting to show your friends. It's because we are going to need it at various times. So the question here says to find the zeros of the function. And it's quadratic, right? X squared. So to find zeros, we put in 0. Right? Now, our first option again is we'd probably try to factor this because it looks pretty easy to factor, doesn't it? Just an x squared. So we would multiply this times this, and that's 1 times 5, and that is 5. And then some review from factoring. Once we have that written down, remember we look at this, it's a positive 5. And what does the fact that it's positive tell us about the two numbers we're going to have to look for?
The same.
The signs are the same because they need to multiply together to be a positive 5, right? So that means either two positives or two negatives. So this tells us they're both the same, both positive or both negative. Then we have to look at this, and this tells us they're both going to be negative. But here's our problem. If we write down the factors of 5 that are both negative, the only options we have, because 5 is prime, is -1 and -5. Does that add up to be -2? No. We can't factor this. Okay, so and we did this earlier, what's our option if we can't factor? Quadratic formula. So just a quick review again, x equals opposite of b, plus or minus, square root of b squared, minus 4ac over 2a. We know that the a value is what? 1. The b value is -2, and the c value is 5. Okay, so we're going to plug that in to our quadratic formula right here. I want to make sure everybody's ready so I don't leave anybody in the dust. Told you we're going to get out early tonight. All right. So, opposite of b. So that's the opposite of -2. Right? Plus or minus the square root of b, -2 squared, minus 4 times a, which is 1, times c, which is 5, over 2 times a, which is 1. Everybody good so far? All right, let's start simplifying. What is the opposite of negative 2? 2 plus or minus the square root of. What is negative 2 squared? Positive 4. Remember, that'll always be positive because you're squaring it, multiplying it by itself. Minus, and what is 4 times 1 times 5? 20. Okay, and on the bottom we have 2. All right, let's keep simplifying. We have 2 plus or minus the square root of. What is 4 minus 20? Negative 16. We have not seen one of these yet looking for zeros. Does that make sense? Because it's always been positive in there so far. But now we can deal with it, right? So what do we do because of this negative?
I.
It's an I, right? Remember the negative inside the radical is an I? So this is going to be 2 plus or minus I. And then this one is a nice one. What is the square root of 16? 4. So actually, let's just write this as 4I. Okay. And now, once we get to this point, remember this is kind of like the ones we just did. We want to break it apart into 2 pieces. Does that make sense? This looks a lot like what we had in the last couple of problems, except for the plus or minus. It was just a plus or a minus. So we break it apart into 2 over 2 plus or minus 4 over 2 times I. And we can reduce the first one to be what? 1. And the second one can reduce to be 2. And just 2 is fine. Okay. And so if I'm looking at my at your test, this is totally fine. X equals this is totally fine, and you're done. But when you type it in the computer, because again, computers are dumb, they have to look for very specific things. Here's how you're going to have to type it in. You're going to have to write these as 2 separate answers. So what are the 2 separate answers? Yep, and correct. So when you type that in, you're going to have to type it in as 2 separate answers, because that's what it's going to look for. There's no plus or minus button for you to use on the computer. So 1 plus 2I and then 1 minus 2I. It's just both of those signs go in between. Okay. Now they all don't come out quite as nicely. Sometimes you might still have a radical left over, like we did in the simplifying, like square root of negative 12. You might have something like that too. But that's where this comes into play, is when we're solving these and we get done solving and it doesn't always come out to be a real answer. That makes sense? You might have an imaginary answer. Okay. So that's why we did this lesson on how do you deal with these I's, because they can pop up in our solution. So you may have some problems that look like this. Find the zeros, but it could be that you come up with some answers that are imaginary also along with your real answers. Does that make sense? So that's tying it together. That's why we did this separate lesson. Some of them are just add, subtract, multiply, divide, and then some will be do what you were doing in section 3.5, but now you might get an imaginary answer or complex answer. Okay.
So will this be on our homework?
What's that?
Will this be on our homework?
This part?
Yeah.
Yeah, that won't be all of it. A lot of it will be the adding, subtracting, multiplying, dividing, but there's probably like 1 or 2 at the end that'll be solved. Okay. And there's our answer. And like I said, if I'm looking at it, this is totally fine. But when you type it into the computer, you'll need to type it separately. Okay. You've got 7 problems to work on there. So I think we had 6 on the other one, I think. Is that what it was? Whatever. So there's 2 sections, and that's it. Again, please, if you guys have questions on a problem, go ahead and ask. And have a great week.